Hello class, and welcome to lesson 5.3b, comparing polynomial functions. Today we're going to take a look at a couple of different things. The first thing we're going to take a look at is what's called order. Now order is different than degree, so you got to be very careful with your terminology. It's common that people get confused between degree and order. Okay, so we don't want to mix those things up. So let's take a look. Common to both odd and even degree polynomials is that, hey, the x-intercepts are called the zeros, roots. You might even have heard them as solutions in the past. Okay. And the graph changes signs only at what we call odd behaviors. So what does that mean? If it was coming from the positive direction, it's going to now go to the negative direction. If it's going in the negative direction, it's going to go to the positive direction. So that is odd order where the signs change. Controversially, the opposite will happen. If the graph does not change the signs at the zeros, then we call it an even order, which means the positive direction, it'll touch maybe like a vertex and come back up. Same with if it's negative, it'll go to negative. Where the order depends on the exponent of each factor. Okay? So let's take a look at an example before we do some questions, and I want to explain this in detail. Here's an example of a polynomial function. It's in factored form. I can tell because the brackets are there. We know that the 3 is just the compression stretch factor. It doesn't deal with any of the intercepts. So we're going to look at this first one. X minus 2 cubed. Well, if you solve that, the intercept's got to be where x equals 2. If we look at where x equals 2, notice the behavior here, guys, as I circled that part. Okay? That's a cubic behavior, so it kind of comes down and does a little swirl. It's not straight through. Okay? And what we want to notice there is when we look at that, do the signs change? It's in the positive direction. After it hits that, it then becomes in the negative direction. So we call that odd. Okay, so that's an odd order, not degree. Okay. Taking a look at the second bracket we have. Okay. If we go to solve that, ladies and gentlemen, x is going to have to equal what? X will equal -1. Okay? What I mean solve is like, how do you get x solved in here? Because remember, to find the x-intercepts, basically y has to equal 0, which means f at x has to equal 0. And then use your distributive law. So if left side equals 0, how do you get the right side to equal 0? Okay? So if we're focusing on that and keeping it color-coded, we're looking here. It's almost like it's a vertex where it starts in the positive direction, it comes and hits and goes back in the positive direction. So notice there, guys, this is called an even order. The sign stays in the positive direction, so it doesn't change. Okay? And the last one we'll take a look at here is x minus 4. Okay, notice there is no exponent attached to it, so it goes straight through, almost like if you think of a linear line. So I'm looking right here where x equals 4. And notice, ladies and gentlemen, it starts in the negative and it goes to the positive. So again, ladies and gentlemen, this is odd order. Okay, one thing I want to add to my graph is sometimes you need to have arrows, so please put the arrows on that. All right, let's take a look at some examples now that we've introduced that. Okay, for example, state the x-intercepts and whether they are an even or an odd order. Well, first of all, we've got to identify them first, so let's start here. Okay, looking at that one, ladies and gentlemen, we notice that x equals -3. Okay, and does it change from positive to negative? From negative to positive, it does, so we call that an odd order. Okay, looking at the next one, we have x equals -1. Looking at that, it starts positive, ends negative, so we call that odd. And we'll look at the last one here, x equals 2. Okay. And that again is an odd behavior because it changes direction. Okay, so if we're thinking what the equation looks like in this case, that's going to be y equals a bracket x plus 3 bracket x plus 1 bracket x plus, or sorry, minus 2. Okay, because those are simple factors because they go straight through. Not so easy over here. Okay, let's take a look here. First of all, I have this one right here, and we'll assume that's 1.5. It's close enough. So we're going to say x equals negative 1.5, and that's an odd behavior because it goes from positive to negative. Next we have, change colors, next we have x equals 0. Okay, and x equals 0 is even, which means it's starting negative and it continues to be negative, right? Okay, and your argument is yes, it goes neutral for a split second, then goes back down. That's true. And then the last one we need to do is we're just going to assume x equals 1.5, and it starts negative, ends positive, so we call that an odd behavior. However, if we're trying to take a look at this equation, we need to notice that, hey, it's going to be y equals a. The first ones are pretty easy. We've got x minus 1.5 times x plus 1.5. But we've got to figure out, how do we deal with this? When we've got a direction changing, that's going to be an x squared component. So I'm going to change that into the challenge here where we're actually going to find the equations. All right? So let's just review this. Okay? So for a, if we want to find the equation, what do we know already? I'll write down what we've already written down. A, x plus 3 times x plus 1 times x minus 2. Now we haven't figured out a, so we need to find a. And this is just an extension, guys. I'm not sure how in-depth you're going to get in the workbook, but if you get to college and you need to do this, I just want you to be able to have had the exposure to it, okay? So if we need to find a, we're going to substitute in a point. So substitute in a point, and let's just say point, let's go the y-intercept. So we'll substitute point 0, negative 6 in. Okay, so whenever I see a y, I'm putting negative 6, so it's going to be negative 6 equals a bracket 0 plus 3 times 0 plus 1, because 0 is my x, 0 minus 2. So we're left with negative 6 equals a times 3 times 1 times negative 2. And all we need to do is find a and then sub it back in. So negative 6 equals negative 6a. To get a by itself, divide by negative 6. Whatever you do to one side, you do the same to the other. So what do we get here? 1 equals a. So therefore, my equation is y equals x plus 3 times x plus 1 times x minus 2. A much easier equation to develop because these are straight, kind of curved changes. If we go back up to that one we started with, that's a little crazy because we've got some cubic behaviors, some quadratic behaviors, and some other behaviors, okay? All right, let's try figuring out this second one. This one is not as easy, okay? So I'll star it. I had mentioned earlier that when we take a look at this, we've got to find a. I'm going to bring the x squared term out front. Then we have x minus 1.5 times x plus 1.5. Okay, so what we need to do is find a. So we're going to sub in a point. And let's use sub point 1, negative 1 in. So negative 1 equals a times 1 squared times 1 minus 1.5 times 1 plus 1.5. Using your calculator or your brain, you're going to get that this is a times 1 squared is just 1, so it's going to be negative 0.5 times 2.5. Keep moving along here. Negative 1 equals negative 1.25a, or plug in your calculator if you're not sure. How to get a by itself, divide by negative 1.25 on both sides. So we're going to get, if you plug that in your calculator, you'll get a equals 0.8, or if you want to keep that in a fraction, it's 4/5. And that's approximate because we were just assuming that those values are there, but it's pretty close. So therefore, my equation is y equals 4/5 x squared times x minus 1.5 times x plus 1.5. And again, that's in factored form, guys. All right, let's take a look at some other information here. Okay. So what does it say here? Let's specifically focus on odd degree polynomials. Okay. Hopefully you remembered last couple lessons at least one x-intercept up to a maximum of its degree. That should have been a summary you did in last day's lesson. Okay. It has point symmetry. So let's just look over here where my point symmetry would be. My point symmetry would be here at this point. So I'll just write it down here. Point symmetry would be at the origin, which is 0, 0. So that's the point around, for example, this shifts to there. Okay, that's from a couple days ago. With a degree of the whole number n has to be greater than 1, must have at most n minus 1 local minimums or maximums. And I'll talk about that in just a second. Minimums and maximums are just where it changes directions. Okay. So taking a look here, if I change my color, guys, this is a what? This is a maximum. So this is a local max. And notice here they also have what? A local min. Okay, in the past when you did quadratics, you only had one of them to deal with. Now you've got a little more than one. So what you can say here is that we have a total of 2 local max mins. Okay? Or min maxes, it's okay. All right, so that's what those are. Local min and local max. And the thing about odd behavior is that it satisfies the property that f at negative x equals the negative of the whole function for all of its x values in its domain. All right, so we're going to take a look at proving that. So it says, for example, f at x equals x cubed subtract 2x. Show that f at negative x equals negative f at x. First of all, let's just double check here, ladies and gentlemen. If we have a degree of 3, that means at maximum we can have what? At maximum, we could have three x-intercepts, okay? But then we also know that when we're talking about the number of local minimum maximums, you take n, subtract 1. So if it's cubic, then you can have at most 2 local min-maxes, which we actually do, okay? All right, now we're going to prove this, okay? So f at negative x equals, so all I'm doing is wherever I see an x, I'm making it negative x. So negative x cubed minus 6 times negative x. Let's do the mathematics. So when you take a negative and you cube it, it's still going to be negative. So it's going to be negative x cubed plus 6x. Now if we want to relate this to the original question, you take a negative 1 out. So it's going to be x cubed minus 6x. And notice, ladies and gentlemen, that this equals negative f at x, because f at x is your original question. So there's the proof. So therefore, the relation is odd degree because of this characteristic. All right. And again, that's degree, not order, guys. I don't want you to get confused. All right. Let's flip and take a look at the even degrees. Okay. So for even degrees, again, you can have a maximum number of intercepts equal to its degree. So if I take a look at this question, I've got x to the 4th. How many intercepts do I have? I have 1, 2, 3 x-intercepts, but I could have 4. It just depends on the equation. Okay. Notice that for even degrees, we have line symmetry, and line symmetry in this case is going right here, down here. Okay. And then we have, sorry for the announcements there, guys. We have a degree The degree, where we're taking a look at the most local minimums, is still the same, n minus 1. So we could have, if there's 4, we could have at the minimum 3 local mediums or maximums. So let's take a look. First of all, that's a minimum, that's a minimum, that's a maximum. So we have 3 local min-maxes. And if you want to be very specific, you've got 2 mins and 1 maximum there. All right, so let's prove this, ladies and gentlemen. Okay, so show that f at x, f at negative x equals f at x. So we sub that in. So f at negative x equals negative x to the 4th minus 2 times negative x squared. So we have x to the 4th minus 2, be careful here, x squared. Okay, and what do we notice that equals, guys? That actually equals f at x, which is your original question. So therefore, because of this property, it is an even degree order polynomial. Okay. All right, last question we'll do quickly. Okay, determine the x-intercepts and state the sign of the leading coefficient. Okay. Okay, well, looking at the leading coefficient, folks, you notice that all of these are singular in terms of their exponents, and it's positive. So first of all, we know is that the leading coefficient is positive. We can answer that one right away. Okay, then to find the x-intercepts, just remember for x-intercepts, you let y equals 0. In this case, that's f at x, so you go 0 equals x minus 5, x minus 1, and x plus 2. Remember, folks, this is the left side has to equal the right side, so you call this the zero product property. So you let each of these brackets equal 0, or just know that x equals 5 is one of them, x equals 1, and x equals negative 2. So those are your x-intercepts. Okay? Come see me if you don't understand that, or just Google zero product property and you'll get that. And let's finish off here, folks. The leading coefficient, taking a look out front, is negative in factored form because you see a negative sign. And to find your x-intercepts, the first one you know is that x equals 0. The second one, x equals negative 3. And the third one, x equals 4. So those are your intercepts. All right, class, here's your homework. Page 91, numbers 1 only, second part and third part. Number 2, 3 ABC, 4 ABC, 5, and 6 ABC. Have a fabulous day and come see me if you need any help. Ciao.